This lecture is on solving a system of equations using elimination, but we're doing it by addition. So in this, we call it elimination by addition. Okay, so let's write down the steps. First thing you need to do is to rewrite. So rewrite the equations in standard form. And if you recall what that means, you want to bring the x and y's to one side, leaving the number to the other side. Okay, so that's what the book is advising you to do. And the next thing you want to do is to do this. This is the crucial step. Okay, that's the step you must understand. You are going to multiply one or both. Okay, so you multiply one or both of the equations by some number. So what number you use depends on which variable you're trying to get rid of. So you need to multiply one or both of the equations by some number so that the coefficients, that's the number in front of the variable, the coefficients of a chosen variable are opposites. Okay, so that is your whole objective. You want them to be opposites. So notice it says here chosen variable, which means it's really up to you which variable you're trying to eliminate. Okay, and then you have to make sure his coefficients are opposites on the two equations. And then what you need to do is you add the resulting equations. So add the resulting equations and solve. Okay, so do that. And remember, you're looking for solutions. So continue to find the solution of the system. And remember, solution is made up of an ordered pair. Okay, so let's go over this steps and let's look at some examples. Let's start with first example. Can you solve 3x plus 7y equals 5, 4y equal 10 minus 6x? So you notice that unlike the substitution method that we discussed, this method is good, especially for systems where you notice in front of every variable there is a coefficient. Okay, so usually elimination method is a bit easier for this kind of cases. Now, for you want to use the elimination method, you must rewrite your equations so that the x and y's are on one side. Okay, so what you have is 3x plus 7y equals 5, and the other equation, that's this one right here, I have to rearrange it. In fact, I have to bring the 6x all the way to the front. So it's going to read 6x plus 4y equal 10. Okay, so what I'm doing here is to rewrite it to look like this. And the reason is because we want the x's to be under the x's and the y's to be under the y's, and so are the numbers. Okay, so they're all lined up. Now the next thing is in step 2 is telling you to multiply one or both equations by some number. So first and foremost, let's decide which variable you're trying to eliminate. And if I'm looking at eliminating x, for example, then I need to make sure the coefficient, that's the number in front of x, they have to be opposites. Okay, so that's the key. They have to be opposites. So that tells me that I'm going to choose the number 6, because 3 when I multiply by 2 gives me 6, but I need them to be opposites. So what I'm going to do is the first equation I'm going to multiply by -2. And what that means, I'm multiplying -2 to every part of the equation. So it's going to read -6x, -14y equals -10. As for the second equation, I'm not doing anything with it, so it's going to read 6x plus 4y equals 10. And the reason why I don't want to do anything is because the variables are already opposites, the coefficients, and so when I add the equations, they cancel. Okay, so that's what step 3 is saying. You need to add the resulting equations, which in this case are these two. and you notice that the chosen variable, in my case x, they do cancel, okay, but the resulting the variable, the leftover ones, they do not cancel. So negative 14 and 4y is negative 10y, but negative 10 and 10 is 0. So I'm going to divide both sides by negative 10, and at this point, remember 0 in the numerator gives you the value of 0. Okay, so now this is the part you need to remember when you talk about solution. It's always made up of two numbers, and y being 0 is telling you the second number is 0, and your job is to find the first one. So to find this one, you have many choices. Pick one. Okay, so pick any equation. I'm going to pick this one, for example. So 3x plus 7y equals 5. Okay, and I'm using y to be 0, so I'm putting y at 0 here. So 3x plus 7 times 0 equals 5. 7 times 0 is 0, so 3x equals 5, which means that x is equal to 5 over 3. So my answer to this question is going to read 5 over 3, comma 0. That's my solution. Elimination is quite a powerful method because it gives you the ability to multiply by anything you like, so long as you do it to the entire equation. So this is especially good, especially if I have the equation and it has all sorts of fractions on it. Like for example, in this case, first equation reads 2/3 x minus 4/5 y equals negative 28 over 15. And the second equation reads 5/4 y minus 5/4 x equals 15 over 4. Okay, so if you don't like fractions, and I think most students don't, what you want to do is to multiply by the LCD, for example. So in the first equation, the LCD is, if you look at 3, 5, and 15, the LCD is 15. So I'm going to multiply the entire equation by 15. Okay, so it looks something like this. Multiply by 15, by 15, by 15. So let's make sure you know how to deal with this. 3 into 15 is 5 times, and 5 times 5 times 2x is going to be 10x. 5 into 15 3 times, and then I need to multiply the negative with the 3, with the 4, with the y. So it's going to read negative 12y. 15 goes into 15 evenly, and so the answer is negative 28. So I'm going to do the same with the second equation. And the second equation, the LCD in this case is 4. So observe that the two equations may not have the same LCD. Okay, so I'm going to multiply the second equation by 4. So I'm going to multiply everything by 4. And the second equation is a little friendlier because 4 just goes into 4 evenly for all of them. So you end up with 5y minus 5x equals 15. So if you have an equation that has fractions, you might have to do one extra step first, okay, to get rid of the denominators by multiplying by the LCD. Okay, so now I'm back to where I wanted it to be, and I need to pick a variable to eliminate. Okay, so I'm going to pick the variable to be x, but before we do that, don't forget to line them up first. So let me rewrite the equations I have there. It's going to be 10x minus 12y equals negative 28. And second equation, I'm going to rearrange it. I'm going to put the x in front and the y's behind, equals 15. Okay, so make sure you line up the x's with the x, y's with y's, and constants with constants. But you do have to take the sign with you, which is why it's negative 5x right there. Okay, now I am looking at the x's, and I think it's easier to match these. I need them to be opposites. So I'm going to choose the number 10, which means I don't do anything with the first equation. But for the second equation, I am going to multiply by 2. Okay, so I'm going to multiply 2 to every part of the equation, which makes it now negative 10x plus 10y equals 30. Now when I add the resulting equations, the chosen variable, which is x, cancels, and negative 12y plus 10y makes it negative 2y, and negative 28 plus 30 makes it positive 2. Positive, not negative. And then I'm going to divide both sides by negative 2, which makes it y equals negative 1. So again, reminding you, solution is two numbers. So y equals negative 1 is just the y, which is the second position. I need to find the x. Okay, so I have many choices. I am going to pick this one, for example. Okay, so you are free to pick any equation. There's many choices here. So the chosen equation I have picked is 5y minus 5x equals 15. And what's happening is that the y is negative 1, so I'm replacing this by negative 1 minus 5x equals 15. So negative 5 minus 5x is 15. I'm bringing the negative 5 over because 15 plus 5 minus 5x equals 20. And if I divide both sides by negative 5, tells me x is negative 4. So there you have it. The solution is negative 4, comma, negative 1. So for example 3, let's look at the special systems. Like for example, in this case, if I were to say, can you solve x equals 2.5y plus 1 and 2x minus 5y equals 3. Now if you're going to use elimination method, remember you have to get the x's and y's to face the same way, or rather to line up. So it's going to read x minus 2.5y equals 1, 2x minus 5y equals 3. I'm going to try to match the x's, but remember they have to be opposites. So I'm going to multiply the top by negative 2. So I'm going to multiply negative 2 to everybody, which makes it minus 2x plus 5y equal negative 2. The bottom equation, I'm not doing anything to it, so it's 2x minus 5y equals 3. Now the original intention was to match the x's, except this time not only the x's cancel, even the y's cancel. So what I end up with is 0 on one side and negative 2 plus 3 equals 1. So if you recall our previous lecture, when the numbers don't match, we say that it is no solution. And the reason why it's no solution is because when numbers don't match, let me write this again, when numbers don't match, the lines are parallel. Okay, so when the lines are parallel and you're looking for point of intersection, you'll realize that there is none. Okay, the last situation, let's look at example 4. Supposedly you're asked to solve 3x minus 2y equals 5, negative 4y equals negative 6x plus 10. So remember to rewrite your equations. So this is going to read, put the x's first. So it's going to be 6x minus 4y equals 10. And the other equation, I'm not doing anything to it. So it's going to read 3x minus 2y equals 5. So all I did here was just to line up the x's and y's. I'm looking for one variable to match, and I'm matching the x's. But remember, what that means is I want the coefficients to be opposites. Okay, so I'm going to leave this equation as 6x minus 4y equal 10. But the other equation I'm going to multiply by negative 2, so that my coefficients are now opposites. So what I'll have now is negative 4x plus 4y equals negative 10. Original intention was to match the x's, but you notice that not only the x's cancel, even the y's cancel, and even the numbers cancel when we add the equations, and all we end up with is 0 equals 0. So just as a reminder to you, when the numbers match. So what do I mean by when numbers match? Meaning they could be both be zeros, or it could be 5 and 5, 10 equals 10, 16 equals 16, doesn't matter. So long as the variables cancel and the numbers match, the remaining numbers, maybe I should say remaining numbers. Okay, when the remaining numbers match, it means the equations are for coincident lines. Okay, so if they're coincident lines, means when you look for point of intersection, they pretty much meet everywhere on the line. And in such cases is where we say there's infinitely many solutions. So towards the last part of substitution method lecture, I did mention that there are basically 3 types of equations. So just to give you a quick recap, the 3 types, first one is called consistent, and this is where you end up with exactly one solution point. Okay, and this happens for intersecting lines, and solution point meaning an ordered pair. The other type was where we talked about dependent, and that means that they are in fact coincident lines. And being coincident lines, it means there's infinitely many solutions. Okay, and the last type is where it's inconsistent, and that happens when you have parallel lines, and when that happens, we say the lines don't meet, or in other words, we say there's no solution.